So in this chapter, we are going to talk about partial derivative. So what you must expect at the end of this video is that you'll be able to, one, partially differentiate first order partial differential equations and also higher order partial differential equations. And also you'll be able to write them in their notation form. And the fourth one is you'll be able to write the partial derivative in a differential form. And the last one is kindly subscribe to my YouTube channel. So let's go. So as from my previous video, we talked about the limit and the continuity of a function. With this video, we're going to talk about partial derivative. So then the partial derivative, as we do it, is that it's in the first order partial derivative and higher order partial derivative, right? So let's get going. So the subtopic here is the differentiation of functions of two variables. So this is the case we're going to do with two variables, which is x and y normally, but it's not always x and y. So for a function of several variables, we consider the derivative of the function x1, x2, and xn with respect to each of the independent variable one at a time. So the independent variable, we do it one at a time. So this is the case that we can do partial derivative of x, partial derivative of y, right? Yes. That means that, let's talk about this. So we are going to deal with partial derivative of x. So let f be a function which involves two variables, which is x and y. So the function of x and y, then the partial derivative of the function, which is f, with respect to the x, is denoted by this. I want you to you guys to note this. This is one of the notation used to represent partial derivative with respect to x. So the partial derivative of the function with respect to x is written like this. And with this is the overview for you to understand. But when you are solving, you understand what you are doing. So the function, the partial derivative of the function, which is with respect to the variable of x, is the limit as the change in x approaches to 0, the function x plus change in x comma y minus the function of x and y all over change in x. So these are expressions that they are giving you for you to have an overview of what you are doing, right? Yeah. So where the change in x is very small change in the variable of x, the same thing to apply, that the partial derivative of f with respect to y is denoted by the partial derivative of the function with respect to the variable y. So in this case, that we are, when we talk about partial derivative of x with respect to, our partial derivative of function with respect to x, that means that we are going to consider only the x variables, but the other variables are not important. In this case, we are dealing with two variables for now. So we are just dealing with x. So when they say partial derivative of x, that means that we are only interested in the variable with x. So any number with a variable x, that's what we are interested with. The same thing applies to the y too. So the y2 goes that way, right? Now let's look at something. These are some notation you need to know, right? So then when we talk about this notation, right? This is partial derivative of x. It can also be written as f of x. And also it can be written as what? The partial derivative of a function over the partial derivative of x. You can also write it in this way. And also you can write it as zx, which is also equal to this. You can also write it in this way. So you should know how you can represent them, right? Please, let's take note of this, because in the higher order, if you don't understand, it's going to confuse you how to represent them using their notation, right? The same thing applies to the y, that is f of y. So if I ask you to find the small f of y, that means you are finding the partial derivative of the function of f with respect to y, as simple as that, right? Yes. You can also have a capital dx of f. It's the same thing. The partial derivative of x with respect to what? Or the partial derivative of f with respect to x. Or you can also say the partial derivative of what? X. Let's take some example for us to understand. So for this example, we are asked to find all the first order partial derivative of the following. So they gave us the function of x and y, which is x exponent 4 plus 6 times the square root of y minus 10. And we are asked to find, if they give you this question for you to find all the partial derivative first order, that means you're going to do it independently. So you find the partial derivative of the function with respect to x here, and you find the partial derivative of the function with respect to what? Y. So let's take this. So for the first one, we're going to do it with respect to what? X, the partial derivative of x, or the function with respect to x. We are just dealing with the x value. But note, if for instance I have this, I write xy here exponent 4, right? In this case, the y is with the x. So when you are doing it, you are going to consider the y to be a constant. Note, if you are partially differentiating it with respect to x, right, and you have a y attached to the x, just partially differentiate the x and make the y constant. But if the y is standing alone, it becomes 0. So for here, we're going to differentiate partially with respect to x. Here, when you are differentiating, you're going to get 4x cubed. That's what they had here, right? But in this case, the y is standing alone. So this whole thing becomes what? 0. And also, when you differentiate the constant, you get 0. You understand? So if the y is standing alone, it's not with the variable that you are finding the partial derivative of. That means that it becomes 0. But if it's attached to it, then you make it what? A constant. Please note that very well. Let's go to the partial derivative with respect to y. With that one too, the x becomes 0 because the x too, the same application. If the y is with the x, you make the x constant here. You're going to make the x constant. But in this case, the x is standing alone. Then it becomes 0. Then you only partially differentiate the one with the y. And you get 3 over square root of y. As simple as that. Let's move on. So in this question, they are asking us to find all of the first order partial derivative of the following. So in this case, you need to know how many variables we have here. So we have x, y, and z. So you're going to do partial derivative of x, partial derivative of y, and partial derivative of what? Z. Let's go with partial derivative of x. So with partial derivative of x, you can write that the function here is w. So the partial derivative of the function with respect to x will give you, as I told you. Now in this case, with this, the y is attached to the x. So we are going to make the y constant. Then differentiate only what? The x. That's why we had what? 2xy. In this case, we don't have x here, so it becomes 0. Here we have x, so it becomes 43. That's what they had what? 2xy plus 43. As simple as that. When you go to the y itself too, the y, there's s squared attached to the y. So when you are doing it, you are going to make the s squared constant. Then differentiate only the y. So when you differentiate y, you are going to get 1. So that's why there's 1 here, but we don't write it. That's why we had x squared minus 20. Here, we have y here. So we are going to differentiate only the y, which is, we are going to bring the 2 in front, multiplying the 10, which will give you 20 y z cube, because we are not dealing with the z, but the z is attached to the x, so it becomes what? It's attached to the y, sorry, so it becomes a constant. That's why we had this to be a constant, and we don't have y here, so it becomes 0. We have y here. When you differentiate it, you're going to get 28 x squared 4y. Let's move on to this the partial derivative, because they asked us to find all the first order partial derivatives. So you need to know the variables that we have here, and then you find them. So with the partial derivative of the function w with respect to z, we don't have z here, so it becomes 0. We have z here, so we are going to differentiate the z, which means I'm going to multiply the 3 by the 30, which will give 3 by 10, which will give you negative 30. Then the y squared becomes a constant, right? Yes, and then you take 1 from here, which will give you z squared. So at the end, you're going to get negative 30 y squared z squared. I hope you understand this very well. You can go over again and get the information I gave you, because it's very important to know that. So let's go to the next one. In this case, they're asking us to find first order. So we have how many variables here? We have w, and we have u, and we have v. So we are going to do zu and zv. With this zu, we are going to use we have the quotient rule of differentiation. So you know that is v du minus u dv all over v squared. Yes, so that's the application they did here, and this the same application, because this becomes u and this becomes v. Now we have 9, because when you partially differentiate this, you're going to get 9. Then we have our what? V. We have our u, and we have our v. So the v here, because we are dealing with partial derivative of u, we don't consider the v, because the v is not attached to the u. So we just differentiate the u, which will give you 2u. That's why they had 2u here, and we bring the v squared. That's how we had this one. The same thing to apply to the v. With here, we are going to consider only the v. That's what they had 5 here, because when you differentiate 5a, you're going to get 5, right? So in this case, whether you are using the product or the quotient rule, you should have it in your mind that when you are doing partial derivative, you need to know how you go about it by getting it, because when it is attached, note, if the derivative you are finding is attached to a variable, then the variable becomes a constant. But if it's independently, then that variable becomes what? 0, as I explained in the video, right? Yes. So these are some examples that you can solve with it. That is some examples you can use the first order partial derivative to solve. For here, how many variables we have here? 1, 2, 3, 4. So that means you're going to do f of u, which is the partial derivative of the function with respect to u, f of being partial derivative of the function with respect to being, as like that. So let's do one and let's see. So let's do the u. I know you can do it. Let's do that. So with the u, you just check here. There's u here. That means that all these become what? Constant, because they are attached to the function, or they are attached to what you are finding the derivative of. So you just bring this to multiply by the a. So you're going to get 16u t cube p minus. So here becomes 0 minus 0 because there's no u here. Then here we have a u here. So you're going to get 4u t. That's all. So it's very simple. You can try your hands on this one. So thank you very much for watching this. The next video I'm going to talk about, or the next topic I'm going to talk about, is higher order partial derivative. Check. That's the next video coming. Thank you very much for watching.